Hi, everyone. Thanks for joining me at NLP Summit. I'm Robert, one of the co-founders of Anyscale, and I'm going to talk about Ray, the system we built to solve AI infrastructure challenges. I'm going to talk about the kinds of challenges that we've been seeing in AI infrastructure over the past few years, how that's changed with the emergence of generative AI. And I'm going to talk a little bit about the trends we see, where AI is heading, and the emerging infrastructure challenges that these trends pose. So to introduce myself and provide a little bit of background, I started doing AI research in 2012. So this was a time it seemed like AI was taking off. Deep learning had just burst onto the scene with the ImageNet results. And I started a PhD in AI research at UC Berkeley. Now, about halfway through the PhD program, I realized that one of the key bottlenecks for AI was really the systems and infrastructure for running AI workloads. And in fact, I realized this because I was spending all of my time managing clusters and parallelizing things and scale things and getting things, to run faster on GPUs and things like that. And so that led us to start Ray, my co-founders and I, to start Ray as an open source project to really try to solve some of these hard scaling and infrastructure challenges in AI. And that's really the purpose of Ray. Really the bet we were making is that AI is becoming more and more computationally intensive. There's a growing need to scale AI workloads, and the need for scaling these workloads across many GPUs or many machines introduces a lot of hard systems challenges. And so that's why we started Ray. And then a few years after that, we started Anyscale to commercialize Ray and to continue developing it. So that's how we got started. Now, before I dive into some of the key hard infrastructure challenges that we see, I want to talk a little bit about how people are actually using Ray today. And this is something that when we started Ray, when we started the company, we had perhaps one serious production Ray user. Okay, it wasn't until ChatGPT and generative AI that Ray really took off, that the need for scaling AI workloads became so much clearer. And since then, Ray has become an industry standard. It's become widespread across companies like Uber train all of their models. Companies like Pinterest use Ray to load the data, pre-process the data, and to scale training. Amazon, which I'll mention, processes exabytes of data using Ray. Companies like Instacart use Ray as the foundation of how they run these batch workloads and scale training. So the adoption of Ray really accelerated with the emergence of generative AI, and that has been an inflection point. A couple examples I want to highlight. So this is from Runway ML, which is a foundation model company for video generation. This video is from Runway. It's fully generated by their model. And companies like this that build foundation models tend to have a few categories of hard workloads. They have training workloads where they need to scale training on many GPUs. They have inference workloads where they need to scale, actually deploy their model and run that on a bunch of machines. And they also have hard data processing and data preparation workloads, okay, where they need to curate the training data, prepare the training data, and make that ready. So data workloads, training workloads, and serving workloads. And these guys are really pushing the frontier. It's one of the leading companies out there for video models, and they've done surgery. These are, you can imagine how challenging, how compute intensive it is to prepare the data and build these models. The next company I want to mention is Amazon. So a very different use case. Amazon processes exabytes of data using Ray. Okay, and by migrating this data processing workload from Spark to Ray, they managed to reduce the costs by an order of magnitude, saving over $100 million a year. So it's a truly massive workload that they're running here. Very few companies operate at the exabyte scale. Of course, many companies have a lot of data, very few companies are truly working with exabytes. And this is a testament to Ray's versatility. And Ray is designed for scale. And you can imagine that every time you increase the size of the data or the size of the compute by an order of magnitude, you're going to break things. You're going to introduce new challenges. And so this is an extremely stressful workload, and really a testament to Ray's maturity and battle readiness. The third use case I want to mention, Canva uses Ray for training all their models. And a company like Canva, they're a leader in the design space. They don't just use one model. They don't just use 10 models. They build hundreds of models internally. And you can imagine these range from more traditional models for recommendations and ranking to content moderation. There's various deep learning models all over the place, including generative models for generating images, for going from text to design, for powering many different parts of their product. And for a company like Canva, AI is fundamental to their business, right? It's really at the heart of what they do, and at the heart of having a great product experience. And so within a large company like Canva, they have a machine learning platform team whose goal, that is tasked with the responsibility of enabling the rest of the company to move quickly with AI, to take advantage of the latest capabilities, to be productive, to move fast. And that's why they turned to Ray. That's why they chose Ray to enable distributed training, to enable multi-cloud workloads, right? To enable using generative models as well as traditional models, as well as both classical and deep learning models, right? All in the same platform. And so the kind of results they've been able to achieve are pretty stunning. So these are a few different examples of the breadth of use cases you can use Ray for. And again, the most common use cases we see with Ray are data preparation and processing workloads and other batch workloads, training workloads, and serving workloads. So we all know that AI has changed a tremendous amount over the past couple of years since ChatGPT. The fact that AI is changing so rapidly is introducing a lot of hard new systems and infrastructure challenges for AI, right? The need for scale is greater. There are many, many new challenges. And AI has not finished changing, right? The changes are happening more rapidly than ever. And despite the AI infrastructure already posing serious challenges today, the challenges are about to get much more significant. So I'd like to share a little bit, because by building Ray, we work with a lot of companies that are at the frontier of AI, companies that are pushing the limits, that are trying to both of AI research as well as integrating AI into their products and building great user experiences around AI. And because we work with all these companies pushing the limits, we have a sense of where the frontier is, what challenges are coming down the road, right? And so I'd like to share a little bit about where we see things headed. The first challenge and also opportunity that I want to call out comes from the scaling laws. So you may have heard of the scaling laws in the context of large language models. But fundamentally, this is the idea that by using larger models trained with more data and more compute, you can get better results. And that's what's shown here. These are curves. This is from one of the original scaling laws papers, showing different model sizes trained on different amounts of data and with different amounts of compute, and is showing that using larger models, as time goes on and as the data increases, the loss goes down, meaning that it's doing better. So what does that mean? Well, companies are looking at this. Companies and are seeing these results. Many of these results are in the language model space and with language modeling. But this principle actually applies more broadly. And companies are looking at this and they're realizing that in order to get better results, they know what they need to do. It's almost a formulaic way to improve their business by using larger models with more data and more compute. And so the machine learning platform teams are looking at this. They're the ones enabling these capabilities. And they're #1 priority. I've talked with many companies over the past few weeks, and so many people have told me the same thing, that their #1 priority as an ML infrastructure or ML platform team is to enable training at a greater scale, enable training on more data, because they're looking at these results and it makes it clear how to get better results, right? And so what does that mean? What are the consequences of these scaling laws? Well, if you're an infrastructure team and your goal is to enable training on more data, every time you increase the amount of data by an order of magnitude or by some large amount, you're going to break things. Things are going to break, right? People don't design systems for infinite scale. They design them for what they need. And so if you increase things scale by an order of magnitude, you're going to need to revamp these systems and the infrastructure enabling that, right? But it also means that it's not going to a one-time increase. The next model you release is going to be trained on more data. The next model after that will be trained on even more data. And this is going to continue. And so this means that the AI infrastructure is not going to stand still. It needs to continue to evolve. It needs to continue to be continually revamped to enable greater and greater scale. And that means that the AI platform or infrastructure team is on the critical path for new model releases and for fundamentally improving the product. And what that means is that this ML platform team has both a lot of responsibility and a lot of potential to really impact the business in a positive way, but it also introduces a lot of risk because the ML platform team is constantly, perpetually going to be on the critical path. And this is simultaneously a big opportunity as well as a big risk, and a big, not just risk to the ML platform team, but to the business overall. Okay, so this is one of the challenges that is coming down the pipeline. If you haven't started seeing this trend in your business yet, for companies that are in production with AI, the North Star is often enable training on more data in order to get better results. Okay, the second trend I want to talk about is the role of data in AI. And when I say that data-intensive AI is rising or growing in importance, that may sound funny because AI has always used data. It's always used a lot of data. Well, there are a number of trends that are at play right now that are taking this even further. And we all know that businesses may spend a lot of money on GPUs for training models. We know that training can be very GPU intensive, very expensive. What we're starting to find now is that data can be even more important than GPUs, that high quality training data can have an enormous impact on the results, on the quality of the resulting model. And so what that means is if you're spending millions of dollars on training, it would be a bad idea to not put a similar amount of energy and effort and money into preparing that training data and ensuring that it's high quality, so that when you go and spend millions of dollars on training on GPUs, you're getting the best results. What does that mean? How do you put effort into getting high quality data? Well, a big part of that is how you process the data. Of course, there's sourcing the data, deciding what data to use, also generating synthetic data, but a big part of it is processing the data. So what does that look like? Well, you have a bunch of data. Some of it will be high quality, some of it will be low quality. Telling these apart, filtering out low quality data is fundamentally an inference task, right? This is an AI task. So you're using AI to curate your training data. For example, in the language model case, my data may be documents, text. Some of those may be high quality documents written by experts. Some of those documents may be generated by a chatbot and may be garbage. How do I tell that apart, right? How do I make sure I'm giving more weight to high quality data and less weight to low quality data? Fundamentally, you need to use AI inference to do that. And it's not just, so filtering is one important role for preparing training data. Another important role is augmenting the data. Imagine you're creating video generation models, right? I'm talking about foundation models and video generation, but this applies broadly. This applies to any type of model you may want to build. And if you have a bunch of raw, unlabeled data that you downloaded or produced or filmed yourself, you may need to augment that data, right? You may need to generate captions for that data. And in order to generate the captions, you may run captioning models, you may run LLMs. And that's fundamentally an inference task, right? You're using a bunch of different machine learning models to actually augment and annotate your data before you run training, right? And of course, synthetic data generation will be even more GPU and AI intensive, right? Fundamentally, synthetic data is about increasing the variety of the data you have, and that is in many cases, that's an AI-related task. In the past, when we did data processing, it was all CPU-based. It was all, if you're working with images, you'd crop the images, or you'd scale the images, or you'd like recolor them a little bit, or normalize them in some way. Now you're talking about using AI to actually do inference and really understand the data before you do training. And that's a very different world. But that's what data processing will look like in the future. And so and this is a challenge because if you think about big data processing systems, they were really built for a CPU-centric world, like Spark. Right? Spark is a mature, battle-tested system for data processing, but it's really built for CPUs and CPU data processing. We've moved to a world that is GPU-centric, where most data processing will not just happen on CPUs, but will actually require a mixture of CPUs and GPUs, where most data processing will actually be done with AI, with machine learning models, right? That's a very different world and a very different set of systems requirements. And the last thing I want to mention about the role of data in AI is that AI workloads are about to become far more data intensive. Why is that? Well, many of us are working with large language models today, working with text data. The input is text and the output is text. But all of these models are going to become multimodal by default. And why is that? Well, fundamentally, you can build far more compelling applications with multimodal data. Even the standard LLM use cases, think copilots for coding, or customer service chatbots, will benefit by having multimodal data. For example, a coding copilot will be able to give you better advice if it can see what's on your screen, or a customer support agent will be able to give you, will be able to communicate more effectively with you if you can send it images or videos of a damaged product. So these are all examples of the reason why all of these models will be multimodal by default. And the thing about multimodal data, like images and video, is that they're vastly bigger than text data. Relatively speaking, text data is quite small. And so all of these AI applications are about to become far more data intensive. And that's compelling. That's a great thing because it means these applications will become way better. But you're going to be in this new regime where you have workloads that are simultaneously data intensive and GPU intensive. And that's fundamentally a new regime. The last trend I want to talk about is growing inference complexity. In the past, we would talk about the role of, when you think of AI inference, you think about hosting a model behind an endpoint. Now, we're starting to see applications like end-to-end tasks, like booking an Airbnb, which involve 50 or 100 model calls, all composed together in a very dynamic way, mixed with application logic. Right? There's going to be far more compute going into inference workloads at runtime in the future. So lots is coming down the pipeline here. So just to summarize, some of the most important trends we see right now are a growing need for scale, because fundamentally more scale leads to better results. We're seeing more AI becoming far more data intensive, and data processing being fundamentally AI driven and GPU driven. And lastly, we're seeing far more compute and complexity going into inference workloads. So these are some of the trends that we see. The last thing I want to say is that if you're interested in learning more about Ray, learning more about these trends in AI infrastructure, come join our Ray Summit in a few days in San Francisco. And that's all. Thank you so much for joining me at NLP Summit, and enjoy the rest of the conference.